Hello. So, as an initiative for next year, to get an organized training program, we have considered starting video lessons. Now, when you make a part in SolidWorks, the first thing you need to do is make a sketch. We hit this sketch button, we will select the top plane. Almost always, you're going to be selecting the top plane for your primary sketch. This is just to keep things nice and well regulated, and a lot of parts, well, you look from the top down on a flat surface. So it just makes the most sense. This button right here, sketch contours, this is optional. I would highly recommend it. Some people don't like it. It helps sometimes when you need to debug an error when you get selected contours, which we don't want. It's not very good. It can cause a lot of issues, but that's not important at the moment. Now, one of the most important things for anyone CADing is our efficiency. One thing that highly affects this is our keybinds. These are extremely important to us. I have a few custom ones, but the ones we have set up for the team on just about if not every computer are as follows. The ones that I remember. A is for arc. This is how you make a circle. You might be asking, why isn't C for circle? Well, C is how we make a construction line, or rather a center line. You'll notice this is solid, but this thing's dashed. This is because it is for construction. If I were to exit this sketch and extrude it, this line would not have any effect on it. I mean, it wouldn't in the first place because it's not connected to anything. It might cause an error. However, otherwise it wouldn't. If it was actually there, if I made a structure out of construction lines and then I try to extrude, this will not show up because these are construction lines. Now, if it's not marked for construction, as you can see this is, it doesn't. Now, you'll notice everything's blue. This isn't fun. Blue means things are undefined. Undefined isn't good. Now, I know you look at this, you're like, oh, let me just set the radius to, let's say, 2 inches. You think, oh yeah, that's fine, it works perfectly. No, yeah, it's still moving, it's still undefined. Which means we need to take our handy best friend, the dimension tool. You're going to hit S. S stands for smart dimension. You can do, for a circle, it doesn't matter how you make this. We would like to have it about level or just at an angle, but this works too. Anyway, so I want this to be a 2-inch diameter circle. Now you notice the first dimension actually sets the scale for everything. So you notice how, although this was originally 6 inches, it's 2 inches, and the scale of this hasn't changed according to it. That's what happens with the first one. However, any dimensions made after that. Oh look, there's another thing. You'll notice this isn't horizontal. It was at an angle. Now, if I dimension this, if you have something that's not horizontal and you want to dimension it, or it's horizontal or vertical, and you want to dimension it, and you're not trying to dimension horizontal or vertical distance between the 2 points of that line, and you want to get the actual true distance, make sure that's what you're measuring, because you'll notice it's from 1.74 to 1.73. If I need this to be a 2-inch line, you'll notice, and here's another keybind, M for measure. You'll notice that this distance right here, your X distance, is 1.9832. Yeah, you don't want that to... if you want to dimension the length of this, you better make sure you're dimensioning the length of this. Otherwise, it may cause issues. Now, I am going to make this horizontal. Now, you'll notice it's turned black. This is for 2 reasons. Number 1, its angle has been set. Its starting point is fixed. And its end point is fixed by dimension. But these two... although both this one's start point and this one's end point are fixed, this point right here, the end point of this and the start point of this, though it doesn't really matter what its end point or start point or whatever, is not dimensioned. It's not fixed in any way. Speaking of fix, this is what we mean. This is a thing. I've never had to use it. You probably won't either. And you'll notice that you've got these things you can do here. Those will not actually define anything. They are... it'll put it there, but it won't be defined. Now, I already showed you horizontal, but here's a really cool thing you can do when you select 2. I can make these perpendicular. Now, you'll notice the angle between these two is now always 90 degrees. So I showed you the Smart Dimension tool. one thing it can do is it can set the length of things, but it can also, and this is really cool, it can also set the angle of things. I'm going to set that as 60 degrees. You notice now I have a 30, 60, 90 triangle. Actually, bit of geometry, because the length of this is 2, the length of this side right here is 1, and the length of this is the square root of 3. So, yeah, this will pop up. Very important that you always save your always save everything. So, when you have something, we'll get you set up with Google Drive. I'll make a separate lesson for that, but you're going to go to CAD and Design. After your Google Drive is set up, you are going to go to your training folder, and as you notice, everyone has a training folder. Let's see, here's mine. I'm going to go here. You know what? I'm going to name this training video demo 1. That's typically not the name scheme you're going to have for your part. You're going to name what it's actually purpose for. I'm just naming it that because, well, this is for the first demo of a training video. Pretty simple. Now, another thing, let me make this not perpendicular so I can show you something even cooler. Is I can make these, well, I can't make them parallel. That'll cause an error. You notice that sketch is overdefined. This item is unsolvable. I can make them, actually I can't make them collinear. Because of this angle, I can't make them, I suppose they could be parallel. If you'll notice, they will collapse into that line. So yeah, they're not going to be parallel. Horizontal, they collapse into that line. Yeah, let me get rid of those. I can also, here's another thing, I can make this vertical. Now, one important thing to know is to know the difference between a line that is horizontal and vertical, and two things are marked perpendicular. Here's an interesting thing. Now, Q is a keybind I have set for a center point rectangle. This is not a keybind that is standardized. It is just mine. If I do this, oh wait, hit escape whenever you accidentally start sketching something again, or when you, oh, I don't want to make a vlog sketch. That's the thing later. I don't use it, but yeah. You'll notice, although the rules of a rectangle are that everything, all the sides are perpendicular. This would be perpendicular to this. This would be perpendicular to this. Rectangles, for some reason, they don't do that, and they just set the two sides as vertical and the top and bottom as horizontal. And with center point rectangle, you get these construction lines crossing. So, an important thing to do, especially if you are using the trim tool, is to delete these relationships and make your, or if you need to change the angle of the rectangles, delete these relationships and instead make your sides perpendicular. You notice, yeah, this is functional. Now, actually, it's really cool. So you'll notice this little thing that looks like a T intersection right here. This is coincident. This is actually a really cool thing. So if something is coincident, that means they connect, or if you were to extend them, they collide, or if you were to extend them indefinitely, they would collide. Now, what this is saying right now is that the midpoint of this is coincident to that point. Alternatively, I could have that set as a, alternatively, I could have made the origin, actually I couldn't have, because you can't make the origin the midpoint of something, and you can't merge the origin into a point. You can only make them coincident. So that's actually why these are coincident. The origin is now coincident with the midpoint of that line, and the end point of this line. Like technically, this line is these 3 points are merged, but if they weren't, I would have this endpoint coincident with this and coincident with that. Now, you notice these two are, yeah. However, yeah, that happens. Now, another thing, you may know another rule of rectangles is that these two are equal. Well, parallel, actually. That's another fun one. Or rather, I meant to hit equal, but yeah, that's a cool one. Now, equal, yeah. And now, if you notice, this rectangle will keep its rectangular properties. And also, I can do fun things like stretch it. Sometimes, you'll notice it's maintaining the same proportions. This is normal. Even though those proportions aren't defined, a lot of times in SolidWorks, things won't want to change their proportion unless they are defined in such a way that is the only way they can move. So if I make this horizontal again, you'll notice it's now actually changing the proportions. But if I make this not horizontal, you'll notice it's merely going to change the scale and the orientation. However, if I was to, let's say, fix this as a length of 1.5, and now you notice now I'm just that is weird, but now I'm just changing the scale of that side, and yeah, it's doing some weird things. And yes, that breaks it because there's center lines that are no longer able to be center lines. There, good. I've got it back to normal. Sometimes reality bends, and we don't worry about that. But yeah, actually, the thing I was talking about with dimensioning. So this is something you want to make sure you don't do by accident. I'm gonna do this. Now, you'll notice, even if like I mark this as 0.7, actually 0.75, you'll notice something really cool. This rectangle, that side length is changing. Why is it? Because what's actually happening is that side length isn't defined. No, rather the x distance between this point and this point is defined as 1.5 inches. So this thing will expand depending on its orientation. Yeah. Oh, I did not intend to do that. Control Z. I meant to delete this dimension. Anyway, so it's another important thing. Now, another feature that is another relation is, let me just do this. So now I'm going to make this line tangent. This is one of my favorite ones. Now, a line can be tangent like this, or it can alternatively be tangent where the endpoint is coincident with the arc of the circle. This means the endpoint is on the circle and the line is tangent. You'll notice this only has one part of the line going away from the circle. That's because the endpoint is marked coincident. Now, let's see. What cool things can I do? Ooh, right there. That said coincident, but really these are merged now. Anyway, you'll notice. And then, that seems cool, doesn't it? Actually, here's time to show off another one of my favorite relationships. Collinear. Collinear. Now, what collinear does is, unlike parallel, similar to parallel, they will have a 0-degree relationship to them. However, their distance in the direction perpendicular to the direction in which they run in is 0. Boom. These lines are now perfectly lined up. And by manipulating this, you'll notice I'm manipulating that rectangle. Let's see. A few other keybinds we have. Actually, I think that's the majority of the keybinds that are set. But some of the computers will have trim entities. This is a very nice one. Actually, let me make this coincident to that edge so I can demonstrate. And then make this a 45-degree angle, just so that I have things nice and defined. And demonstrate the trim tool. Most computers will have this defined as, this will have T, except for there. Now, I'm going to go cut. That dimension will still work. Sometimes it won't, but it's continuing to work at the moment. Now, you'll notice these lines turn blue as I deleted parts of the rectangle. That is normal, because there's no longer anything defining them. However, if I set the distance between these 2 points, 0.75, it's nice, and, where did our hand... Let's see. Now, this is still saying it's undefined. Sometimes it'll say it's undefined and you have no idea why it's saying that. And there's why. These were never defined as equal, which is very interesting that SolidWorks doesn't do that. That's conflicting geometry. Interesting. So, instead, you know what I'm going to do? I'm going to make that coincident to the circle. Now, it's fully defined. And you'll notice now this whole thing is filled in one color. Earlier it was like, when I cut that, this turned white, but before it was like this blue, and then where the rectangle was, it was a darker blue. That's because they were two separate contours. If I do something like that, either one contour is going to cut through the other, or if I've got contours intersecting like a Venn diagram, I'm going to get an issue that requires me to use selected contours, which is not something we want to do. Selected contours is the bane of my existence, to put it shortly. It is not good. If we change a cut extrude or an extrude, the sketch behind a cut extrude or extrude sketch, it will not update unless we manually select each contour. It's not fun, especially if you have a lot of holes. Yeah. So after I exit the sketch, I am going to extrude boss base. Now, this is how this sketch becomes an actual part. I'm going to use our most common sheet metal thickness, and that is 0.09, or as we call it, 090. Now, here's another keyboard shortcut. N will normalize. This can normalize to a face, a plane, or any flat object. You can't normalize to an edge or a curved face. It just doesn't work. Another important thing for every part is to have a material specified. When you don't have a specified material, you'll see it's this color. Our most common material is 6060, so we're going to go to aluminum alloys, and it is called 6061-T6SS. And no, this has nothing to do with Germany, don't worry about it. We're going to hit apply, and then close. You'll note the colors change slightly. It's kind of imperceptible until you see a part that does not have a material defined next to a part that does. Also, other materials have different appearances. Like if I make this polycarb, ABS-PC, you'll see that it's turned clear. And it's also like this white color. That is what polycarb looks like in SolidWorks. However, we don't have 090 polycarb. Polycarb will be 0.25. We can also 3D print an ABS. And if you make a part like that, it'll look like that. Different materials have different appearances. It's pretty cool. But mainly what we use is 6061-T6SS. Really, it doesn't matter what 6061 you're using unless you want to use SolidWorks simulations, which we have not worked out how to use very well yet. So that, if there is a lesson in that, it will not be coming for a while. I mean, maybe by the time anyone sees this video, we'll already have worked it out, because this is filmed just as off-season as beginning, but that's not really important. Oh, another thing. Whenever you make your part, your first boss extrude will be titled, not edit, but bank, that's how you'd edit a part, but go to rename tree item, and I will name this 0.09, thickness of sheet metal, 6061. So we do. When you make a feature, like let's say I make an extruded cut. Here's another thing. When you make an extruded boss base or extruded cut, you can either A, make a sketch first and then turn that into extruded boss base or extruded cut, or B, click the tool, and if you don't have it, you can select a sketch that already exists, or you can click on a face and make a sketch. So what I'm going to do is I'm going to make a line. This line is going to be 1 inch long, and I'm going to set the origin as the midpoint of this line. Now, here, here, and here, I'm going to make 3 circles. Now, I'm going to set these circles as equal, and I'm going to make the diameter 0.196. 196 is the most common hole diameter that we have for putting bolts through. This is one of the numbers you will memorize. It is 196. You got 196 holes. This is your 1032. Rather, just your number 10 hole. The 32 refers to the thread pitch. Now, here's when we make a cut extrude, we can set a depth manually. So I'll see 0.1, and you'll notice this goes slightly through the part. So if I was to extrude this 0.01 inches, it would still cut through it. But if I extrude it further, it won't cut through the whole thing. Through all, which means if there's material in that direction, it's going to cut through it. Through all both, if there's any material that is perpendicular to the face of this sketch that intersects this geometry, it will not be there. Up to next, this is the most important one. This will cut up to the next side no matter what distance it is, and if there's a gap, it won't cut up to the side. Up to vertex, we don't really use that one. Actually, let me turn off direction too. And then up to surface, manually select a surface. Okay, up to surface, and you must manually select a surface for which it will go up to. Very interesting. I don't know what's... Direction 2 is still acting up at the moment, but yeah. Up to surface, face 1. You've also got offset from surface. We don't use that a lot. Up to body, don't use that one either. Or mid-plane, I guess that would go... I don't know why it's doing it both ways, but yeah. These aren't things we typically use. Preferably, you will use up to next unless something has to go a specific distance that is not all the way through the part, such as, let's see, when you need to make a when you need to make a standoff hole on a gearbox plate. Actually, I can demonstrate one of those right away. So I'm going to go File, Open. I'm going to go to my very own training plate. That's SolidWorks simulation stuff I was messing with. But my very own training gearbox plate. And you'll notice that it looks amazing. Don't worry about its configurations. We'll make a lesson on those later. These gray things are suppressed. Don't worry about that. Again, that's configurations. There will be a lesson on that later. You'll notice the edges are rounded. That's fillets. We'll make a lesson on that later. But mainly, what was I? Actually, what was I even focusing on? I forgot. But oh yes, standoff holes. You notice these little guys. I have a separate cut extrude for this from any of the other holes, and these are set to go 0.125 inches into the material. Typically standoff holes will go half, they'll either be 0.125 or 0.1 into your 1/4 inch 6061 aluminum. It might be 61. We've got 3 types of aluminum. We've got 6061, 5052, and 7075. 6061 is our standard type. 7075 is for very specific applications that require a lot of strength, and 5052 is for things that we want to bend with bent sheet metal. That's a whole nother can of worms. I know I'm mentioning a lot of things that are kind of way beyond just a basic first lesson, and I'm showing things that are really advanced too, this gearbox plate, but these are important. They will come up later, and as complicated as this may seem, my hope is to do what my teacher taught me, what Jack taught me, and although this kind of thing looked impossible for, if not a while, at least the first day, very quickly this seemed possible, and my hope is so that you will get a similar experience. Although this looks ridiculously difficult, I know. Gearboxes were our final projects for my CAD training. It may be that way for yours. We haven't decided yet, but believe me, as impossible as this looked day one, after a few weeks when we started this, it seemed really achievable. And we were all able to achieve it. Myself, Johnny, Nick, we all designed our own gearboxes. They all were ones that could have worked on an actual robot. But that's a lesson for another time. We'll actually have a specialized unit on that. It may be your final project, it may not be. We're still setting things like that up, but yeah. Enough about gearboxes and about my CAD training. So what I've gone through is the basics of boss extrudes, sketches, cut extrudes. Cut extrudes, so sometimes we would like to name our cut extrudes the purpose of that. So this will be centerline, capitalization, centerline 0.196 holes. That makes it so anyone who's trying to navigate through this feature tree can find your things so much easier. I remember at one point, a part I had made had been edited, and it was really hard to figure out what was doing what. Like, not to point fingers or make anyone feel embarrassed, but a few choices had been made in the CADing process that were less than ideal and could create some errors, and the only way to fix them was to remake a vast majority of the changes that had been made. Like, start from scratch, delete all of them. So, unfortunately, we had to leave those in. I may show that at one point as an example of what not to do when CADing, but for the moment, like, please try and keep your feature tree organized, say what's going on there, make your part name obvious, what it's for, and overall, don't do bad CAD practices. We used to have a bad CAD practices stick.
Ronan Gordon.
Hello.
I need your attention.
I'm recording.
You did not talk to me that you were recording, and yet we were supposed to be making the lesson plan together.
This is a demo.
I feel like this is a,
Hello, I'm pretty sure the mic is picking this up. This is a demo, and we're going to play it, watch it afterward. We may use it, but I'll have to cut this part out.
Well, then say that next time, okay? A little communication. Thank you. You may continue.
I feel like when I'm not there, but my stuff is still there, you could probably figure out that I'm recording.
I asked your father where you were.
You should have asked Max.
You said you didn't even have OBS on your computer.
I said I did. It wasn't on the computers here. Anyway, yeah, that's Khalil. He's helping me with this. Yeah, but that's... Don't worry about the stuff there. That's about it for now. That's all we planned. Actually, that's more than I planned to put in this lesson, but that's okay. This is a trial run. We're going to look at this, look back on it. I noticed that my mic audio is peaking, so I'll actually have to lower that. And I've also noticed that this is too long for me to post to YouTube at the moment because I'm not able to post videos longer than 12 minutes, but that's not a big issue. Anyway, well, OBS only uses 0.7% of my CPU. Don't worry about that. Anyway, so there's a small chance that you will be watching this video because this has been the trial run, but if you are, hope you've liked it, and I hope you find this lesson informative. Thanks.